Welcome to Vectors and 2D Kinematics. First, I will go over the difference between a scalar and a vector. Then I will talk about the basics of vectors in a coordinate plane. And then I will talk about multiplication and addition and subtraction of vectors. So let's get started. We have scalars and vectors. The difference between scalars and vectors is that scalars have magnitude, while vectors have magnitude and direction. Some examples of scalar are distance, speed, and acceleration. Some examples of vectors is displacement, velocity, acceleration. Here you have to be careful because the units for distance and displacement are both meters, the units for speed and velocity are both meters per second, and the units for acceleration on both of them are meters per second squared. So be careful that you know if you're using scalars or vectors. On to 2D kinematics. So here's a coordinate plane, an xy plane. The big thing with vectors is to be careful where your angle is. Make sure that whenever you're trying to get your adjacent side to the angle, you're using your cosine theta. Many of the times, 9 times out of 10, it's going to be on the x-axis, but be careful where your angle is. If it's up here, it would be sine theta, so be very careful. Whenever you're going to the opposite side of the vector, or of the angle, use sine theta, which is the opposite, so use your SOHCAHTOA rules. Whenever you're adding and subtracting vectors, make sure you use the tip-to-tail method and go from there and practice from there. If I were adding this vector to this vector, I would make sure that this tip here is onto this tail, and the resulting vector would be this. You can use multiplication of vectors using the dot product, which will result in a scalar value. And you can also use multiplication of vectors using the cross product, which will give you a vector value.